Hi, today we're going to work about pre-lab and data and a little bit about lab safety again, just remembering the things that we need to remember in lab. Remember to read labels, remember to wear goggles and an apron. Remember, gloves we're not going to be using as much, but no food or drink. Goggles are important, and no flip-flops or open-toed shoes. Cell phones are great to leave outside of lab. Unless we need a timer, then you might need to bring them back in, but you'll not want chemicals on them. So let's talk a little bit about some other general safety precautions. We don't want any horseplay in lab. We want to be aware of others in lab and what's going on around us. You shouldn't be in the lab or preparation area unsupervised. You need to be prepared for your lab, meaning you need to have gone through your pre-lab and read through your procedure so you know what you're going to be doing. Make sure you know any safety precautions before starting lab, and I will go over some of those. Do not eat, drink, or chew gum in the lab. Chewing gum is very important that you don't do in the lab. And your food may pick up harmful chemicals that come out in the air. As far as contacts, I'll be telling you the ones that sit into contacts, and so before we do them, if you've got glasses, that would be a great time to bring glasses. If not, you'll need to bring your solution so you can wash them out really well after. And don't ever taste anything in lab. So, and no flip-flops, and bring something to tie your hair back if you've got long hair. So let's talk a little bit about pre-lab. Now you should have out your notes, your study guide, so that you can take notes while you were doing this. Again, you can stop this, forward it, whatever, as you get things done. So problem or observation is, what is this lab about? What are you trying to do? So we're not just giving you labs to give you labs. There's a reason behind it. What is the reason we're doing this lab? A lot of times you won't be asked for your hypothesis. Sometimes you will, but you should always, having done the pre-lab, try and figure out what are you going to see during lab. What do you think will happen? What do you think your results will be? So that when you get back in lab and you get something that is bogus, you'll understand that it's not, that can't really happen. Something's wrong. As we're working in lab, when we're gathering stuff, we're going to have some variables, and you need to be able to identify what kind of variable they are. There's 3 different types. The first one is independent. This is the thing that you're going to change. And because you change this one, we get dependent variables, which are dependent on what we changed. So independent is what we changed. Dependent is what changes because of what we changed. And then the controls are the things that we're going to hold steady, that we're not going to change, so that we have a valid lab. So again, 3 variables that we're going to be working with. So let's practice this, see what we can figure out. So here's a practice. The higher the temperature of the air in the oven, the faster the cake will bake. Okay, so what are we changing? Well, hopefully you put the temperature of the oven. And as we change the temperature of the oven, what happens? The cake bakes faster. Good. Well, what are we holding constant then? Well, you better say the cake batter in the oven, because otherwise we're changing a whole bunch of things. We have a few practices here to get you going well on this. So let's go to the next one. A student measured the temperature of water at different depths in Lake Skywalker and found that the temperature varied. What was the independent? What are we changing? Or what was the student changing? Well, the depth that he took the sample, right? Or she took the sample. Because we took it at different depths in the lake, what else? What changed? What was dependent on the depth of the lake? Well, the temperature. And what were the controls? Well, they didn't say, but probably sample size was one of them, and the lake. We didn't change the lake. All right, one more. The amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. Again, what are we changing? We're changing in the amount of lead. And what's dependent on us changing the amount of lead? Well, it's the pollution produced. Good. And what are we holding as controls? Well, the cars. And we're putting gasoline in the cars, but the gasoline contained different amounts of lead. All right, so going forward, we're going to be, as we go back into lab, we're going to be taking or recording data or observations. There's 2 types of data that we're going to gather from lab. And you need to make sure that you do a good job at either one. First one's quantitative. This is any number that I take. For instance, if I'm measuring something with a ruler or a balance or a graduated cylinder or a beaker or a thermometer, anything that has numbers, that's quantitative. And I want to get as many numbers significant as I can. We'll talk about significant figures a little bit later. Qualitative is what I observe. Now, as we go around, did a sound change? Did it make a loud noise? Did it fizz? Can I see with my eyes a change that something's going on? Did it change color? Did it bubble? Did it disappear? Sometimes it's the texture. Here it has touch. We're not necessarily going to touch things in lab, but the texture of it changed. Maybe it was smooth and now it's rough. Did the smell change? It gave off an awful odor. And we don't do taste in lab unless it's a food lab, and that will be in the classroom. But we would observe the difference in taste. And there are some labs that we will be doing that. That is a food lab in class. All right, so going forward, a little bit more about, so this is an example of qualitative and quantitative data. And they sort of switch sides. So this qualitative is on this side. This was the observations, the things that we can touch, our senses. So qualitative. So if we had an oil painting here, the qualitative data that we could look at and say, oh, it's blue and green, it has a black road, it has a gold frame, it might smell old and musty. We could look at the textures of the brushstrokes and explain them. We could say it's a peaceful scene of the country, and we could say that something else about the stroke, saying that it was masterful, it was beautifully put together, not a kindergarten's first grade attempt. On the quantitative side, using that same oil painting, we need numbers. So thinking numbers, how big is the painting? Well, the picture is this big by this big. With the frame, how big is it? How much does it weigh? What is the surface area that's painted? What's the cost? All of those are numbers, quantities. So we're going to do a couple labs, either you have or you're going to do, I should say, with the rotation. One is gathering qualitative data, which we're doing observations, and we're not really writing any numbers down, and that's the tape lab. And so we use Scotch tape and balloons. And the other one, we're actually going to be using metric sticks and stuff like that to be able to measure things. Now, I told you we were going to talk about significant digits. Significant digits are very important in that the significant digits in a measurement consists of all the numbers we know plus one digit past what we know that's uncertain but that we estimate. So if I'm looking at this gray block right here, the numbers I know for sure are 1, and then I can count 1, 2, 3. It's more than 3 but less than 4, so I could put 1.3 for sure, and then I estimate in between these. It's a little bit more than half, so 0.06 or 0.07 would be fine, so I would report 1.36 or 1.37. That last number is uncertain by 1 either way. So that's what we talk about significant figures. I don't write 1.36253 because I don't know those. I can only estimate 1 in between the mark that is given. So let's look at this one down here at the bottom, the wood one. Using what I just told you, what would you report for this? And I'm going to give you a second. Okay, so coming back, we know the 4 for sure, right? So we're going to put the 4 there. Then point, and we count 1, 2, 3, 4, 5. So I put 4.5 for sure. I know that it's at least that long, but it's not quite to 6. So this was where the estimate comes on the next one. So 4.5 what? Well, it looks like it's about halfway through. So 4.55 would be a good measurement for this one. So see how I'm estimating that last digit? That's what significant digits do. And when we do calculations with them, it helps us to know, oh, I didn't measure it to 5 after the decimal. I only measured it to 2 after the decimal for this one, and 2 after for this one. So it tells how well we measured things. So here's another example where we have a pen and we're estimating between, the picture is not that great, but this one is 4.7 for sure, because 4 and then 7 lines. And then we estimate a little bit more than that, so 4.72 or 4.73 would be good. So you can sort of get the idea here. All right, that's all for today. So go ahead and work on your assignments.